Hello and welcome back to Get Kafka-Nated, the show where we explore the fascinating world of Apache Kafka, from architectural deep dives to the people who make it all happen. I'm Hugh, your host, and I'm excited to be back for our third episode. As always, we've got a coffee on us for our live audience. You'll find a link to claim your voucher in the chat. Quick reminder, it's currently available in Europe and North America, but we're working hard to expand this globally for future episodes. Before we dive in, I'm excited to announce that we're launching the Get Kafka-Nated blog this week, a written companion to the podcast where we can explore the technical concepts we touch on here in a much greater depth. This week, we'll be sharing a deep dive into Diskless Kafka performance testing with real benchmarks and production configurations. You can find all of this over at getkafkanated.substack.com. And if you subscribe, you'll get weekly technical content plus updates on what's happening in the Apache Kafka community. Today, though, we're diving into one of the most ambitious architectural proposals in Kafka's recent history, Diskless topics. I'm delighted to welcome Greg Harris, the open source software engineer and contributor to 1150, which introduces Diskless topics to Kafka. Welcome to the show, Greg.
Thank you so much, Hugh. I'm very happy to be here. So, hi everybody. I'm Greg. Hugh gave me a great introduction, and I'm very excited to talk to you about 1150 today.
Awesome stuff. So, just as before we dive into 1150, a quick question on that point around being an open source engineer. What's it like to be a professional contributor to an open source project like Apache Kafka, and how's it different to maybe some other sort of engineering roles?
Well, in one word, it's fantastic. I love being an open source engineer. I love being an open source contributor. I really love working on open source software. It really it distills a lot of the values that I have for software and distributing it to people that really need it and make a lot of use out of it. And one of the best parts that I like about it is basically not wasting work. You know, if you are contributing to an open source project, that those changes are going to be there for years and years, and people are going to get lots and lots of value out of it. And there's a lot of risk in enterprise software that you work on something and then suddenly it doesn't become a business priority, or it becomes replaced by the next big thing. And I find that really, really nice about open source software.
Amazing. That's super cool. I really like that point around like reducing waste. So the idea of like if something's an open source, that people can keep building it and using it, and you're never gonna have a day where someone's like, well, we have a new product and this is gone.
Yeah.
That it'll always be there to keep building, and that as an engineer is super cool. So on 1150, let's start with the core problem. Can you walk us through what problems Diskless actually solves as this new kind of model for Kafka? And for teams who are already running Kafka in the cloud, what are the pain points that 1150 is addressing?
Yeah, so 1150 really is motivated by a lot of different aspects about Kafka that all negatively like affect operators, and all seem to come from the fact that they have disks attached. So just like any stateful system, you have to have like storage, and when you have storage, you have to manage that storage. You have to manage moving data around between those storages. And for Apache Kafka in the cloud, that means that you have to pay a lot of replication costs. You have to pay a lot of time and latency in actually getting that data between different nodes when you're doing, for instance, a rolling cluster upgrade. It makes, because you have this sort of dead weight of disks attached to a Kafka cluster, it makes it a lot less agile. So it's harder to do sort of operations on it. And 1150 being Diskless Kafka, we're trying to remove the remaining disks that are attached to Kafka in the like active segment. And that is going to unlock a lot of new use cases for Kafka in the cloud. And it's going to make Kafka, like a lot of people have called it sort of truly cloud native for a while now, but truly cloud native Kafka, I think.
Super cool. I like that idea of like shifting away from relying on disk-backed partitions, being that push towards Kafka being more cloud native. On that point though, around Diskless, I know it's kind of a weird one. I think some people say it's a bit of a misnomer, but it's Could you speak a little bit to the distinction between like the idea of diskless Kafka in the sense of like, oh, like completely serverless, like there's no disks at all, or diskless Kafka in the sense of like where are there disks still?
Yeah.
For like metadata and stuff like that, and why is specifically moving from one area of disks to another?
I really like that you brought up serverless, because that's the comparison I like to make. Is that diskless? It is diskless in the same way that serverless does not have servers, which is to say that there are disks somewhere. Like the cloud is just somebody else's computer. So we don't promise that there are no disks somewhere in the tree. But basically, the name of the KIP is Diskless Topics. The feature sort of maybe gets corrupted a little bit to be talked about as Diskless Kafka. But the focus really is on the data in the topics, and that is what sort of traverses without disks and goes straight to object storage. So in traditional Kafka, that data in your user topics is actually on disk somewhere. But in diskless topics, that user data is actually in object storage. It doesn't really, like, Diskless doesn't refer to, like you said, the metadata, which is basically instructions on how to retrieve that data from object storage. We have to sort of keep something outside of object storage. And it also doesn't apply to cluster metadata, which is sort of which topics exist, who has access to them. And it also doesn't apply to like internal implementation details of Kafka. So stuff like the offsets topic, which is dealing with consumer offsets. It doesn't deal with transactions. It doesn't deal with share groups and so on. So when you're running with primarily diskless topics, you still actually have a lot of disks attached to your cluster, but they're only storing sort of the metadata about your data, the design of your applications and that sort of stuff. The actual like data that's heavy, that really is causing operational problems and getting to excessive costs, that stuff is now in object storage.
That makes a lot of sense. Yeah, it's interesting thinking about like, yeah, even with serverless, there's still a server there, but it's abstracting that away. That's kind of providing the value, right? I think we touched on there some like internal topics and components of Kafka. So I think, would it be fair to say that even with Kafka having this focus on like keeping the broker as simple as possible and shifting logic off into the consumer and producer, like there's still a lot of complexity in Kafka under the hood. And with that, what was the technical challenge for you as one of the contributors to implement this change? So, you're essentially rerouting Kafka's entire replication pathway from broker disks to object storage for these particular topics. How do you do that whilst maintaining the behaviors that people expect from Kafka, like ordering or performance, whilst making such a fundamental change?
Mm-hmm. Yeah, that's like the $1 million question with this feature is how do we make everything else work and still get all of the positive benefits that we want? And in the open source style, the way that we get all of those properties is we reuse a lot of what's already been written. So when I said that we're reusing the internal topics, we're reusing them as is. We're not changing anything about how consumers are coordinated, how groups are coordinated, how consumers store their progress. We're not changing anything about how the transaction coordinator organizes transactions. We're changing as little as possible in Kafka while still focusing on the areas that actually need development. And in particular, I do have to say that like a lot of the problems that people do have with Kafka today, which is like choosing your partition count and scaling up your applications and dealing with fan out, they're still going to exist with Diskless Kafka because a lot of the decisions we've made in keeping the existing protocol and in keeping the existing technology. So the changes that we've been most concerned with, or that we've been putting the most design work into, is actually exactly what you talked about, actually preserving the order while getting these other properties. We had to switch to sort of a leaderless design so that we don't have, like, you don't have to contact a particular leader with your producer. But that required basically designing a new component, the batch coordinator, that takes on a lot of the responsibilities that a leader in classic topics would have to manage. So it's dealing with idempotent producer state. It's dealing with actually like providing a total order to all of the batches as they come in. And so, yeah, the batch coordinator is really doing a lot of the heavy lifting in the new design.
On that point around the batch coordinator, So I've been doing a lot of digging into Discless just because
Mm.
that's kind of my lot in life now, as I'm a person who finds Kafka interesting and reads and writes about it. I've seen a lot of people talking about like, oh, we're going to use like Postgres as our like metadata store for the batch coordinator, or we're going to do it this way, or we're going to do it that way. Where do you see this new kind of batch coordinator logic sitting versus like how it's implemented now? Potentially like down the line, like what do you think this looks like in like a finished version of Discless?
Yeah, definitely. I can say that the batch coordinator design and implementation is very much in flux right now. Part of the reason why there's even Postgres being discussed right now is because it was just sort of the quickest to market sort of solution. In my design documents, I said, okay, we're going to go out with the V0 of each of these different components. So the V0 of the batch coordinator. And then sometime around now, we're going to switch to the V1. And then we're going to switch to like a V1.1 once we like get performance testing done. And so we're still very much on that journey. Where I see the batch coordinator going is either it remains pluggable. We have a sort of topic-based batch coordinator that we're going to try and get into the mainstream or get into mainline Kafka, and I expect like almost everybody to use. And then possibly again, if it remains pluggable, I could see somebody substituting a very very scalable storage system for the batch coordinator, something like Spanner, for example. That design is sort of up in the air right now. It may not be pluggable in the future, and it may be that the topic-based batch coordinator is sort of the only game in town, which is not a bad thing because it means that there's less stuff to set up. You just plug your Kafka into like a backing Kafka topic, and now you don't have to deal with a second Postgres instance. So that's where I really see it going, is that we have basically classic topics handling the coordination for diskless topics. It's sort of a self-hosting manner.
That makes a lot of sense. I like that as well from the perspective of someone who has to operate Kafka. It's like, oh, how can we reduce the number of components here as much as is
Yes.
humanly possible?
Yes.
I imagine that's also very attractive as a contributor and a maintainer of some of this code. Is like, well, let's use what we've already got because we know it works, right? Like rather than having to reinvent.
With the advent of KIP 500 and the removal of Zookeeper, there's a huge focus on making Kafka sort of as self-contained as possible. And we've seen that in the tiered storage design where Kafka doesn't want dependencies on all of the different blob stores. And so we have to have out-of-tree plugins. And I think that we're going to see a little bit of that to continue, where we want Kafka to be as self-sufficient as much as possible, and sort of like you stop at the object store boundary. But yeah, there's a lot of stuff in flux there.
Touching on removing Zookeeper and other kind of Kafka improvement proposals that are sort of have made a really big difference recently. I mean, removing Zookeeper has been awesome from the perspective of operating Kafka. No noise on Zookeeper. It's just a lot controversial take. It's a lot more fun and easier to use KROF than Zookeeper. Who thought?
Yeah.
But this KIP, like some of those others, has been structured kind of like as a motivation KIP, right? Which in the sense that you have the parent and then you have multiple follow-up implementation improvement proposals. I think we're seeing that a lot more now in the open source space potentially, but I think that's kind of different from maybe how things were done a while ago, where you'd have like well, this is the feature and we're dropping it all in one go, right? What's the strategy behind sort of breaking up a change like this in this way into lots of these smaller KIPs?
A lot of the motivation behind sort of splitting it up is just to make it easier to review, which is a classic in PR reviews and stuff like that. And it's really important in the Kafka community because there's a lot of discussion that goes into like the KIPs themselves. There's a lot of stuff that gets planned out before the KIP even gets approved. And then afterwards, like the PRs just sort of like do themselves essentially. Like all of the hard design decisions have already been made. All that's left is to actually like implement it. And at least the strategy for us definitely was to try and get the community behind the need for this feature first, and the specifics of how we were going to do it sort of second. So a lot of the language in KIP 1150 and some of the stuff that I think is most potent is saying that competitors to Kafka have this feature. Why don't we? If competitors have this feature, like it's just going to suck users away from Apache Kafka, and one day we'll be in a state where like the Kafka protocol is either stuck in place forever, or is like subject to a committee like the IETF or something like that. And I think being a Kafka contributor, I really want to see the Kafka project own its own protocol and be able to continue innovating and not sort of involve or not get into that state of community yet. So the 1150 is primarily a motivation kip and doesn't actually bind anyone to any particular implementation. There doesn't have to be a batch, like there's no batch coordinator mentioned in there or anything like that. It's just a simple, hey, we need a way to like save on replication costs. We need a way to like use object storage natively that isn't tiered storage. And all of the subcomponents are just sort of like what is reviewable at the time. So we have a core kip that discusses the overall architecture, and then a whole bunch of kips that sort of slot in saying like, this is how we do this aspect of that core kip functionality. This is how we do this other aspect. With the goal that the conversations on each of those can be productive and we can sort of make forward progress, and that we don't get sort of stuck in bike shedding, or we don't provide a kip that's so big that it's unreviewable. Those are sort of what we wanted to avoid with this strategy.
That makes a lot of sense. So would it be fair to say then that 1150 is as much kind of a making the case for a modernized Kafka and a future of Kafka where, you know, we're doing these sort of change issues which support more like cloud-based use cases and things like that, and
Yes.
Reducing costs for operators, as much as it is saying we have this specific technical idea and implementation that we think is a way of doing that, right?
Yeah, 1150. I've been trying to promote it as sort of a big tent kip, also, which is to say that we established the need for a feature like this, and we have a favorite, which is 1163, but we're open to ideas from other people about all of the other different ways. So we've seen two other kips related to 1150. So there's the essentially the auto MQ proposal, which is them trying to upstream their own interfaces into the project and be able to establish something similar to a diskless topic, and also the I call it the Slack proposal. Forgive me, I forget the numbers, which is talking about tiered storage for the active segment. So I think all three of these kips are all in the same space. They're all sort of under 1150. You could accept 1150 and then accept any of the others. But we do have a particular implementation that we feel is the most attuned to the goals set out in 1150, and that's why we're backing it. That's why we are putting our money where our mouth is. That's why we're working on an implementation. That's why we're working on productionizing it, is because we do believe that we have sort of the best option for the community overall. We just sort of have to work with the community to make sure that they understand that their needs are met with the implementation, that all of the sort of pieces fall into place. And that's what the KIP discussion is all about, is making sure that the community is involved in our decisions as well. We're not long-term forking Kafka or anything like that.
That makes sense. And yeah, I can see that as an important distinction, where it's like, you don't want to be in a position where you're like, oh, we now have a new offering, which is based on Apache Kafka. It's Apache Kafka compatible, because like there are already offerings out there potentially in Red Panda and elsewhere, where it's like, oh yeah,
Yes.
well, there is an equivalent of a diskless offering, but it isn't within open source Kafka.
Yes, there was a critical moment in our decision making, which was, do we want to be the eighth player to a crowded space of improvements to Kafka that are based on disk storage, or do we want to be the first one in the open source space? Do we want to actually get it into Apache Kafka? And for me, that decision is very easy to make, because by getting our change into Apache Kafka, like I said, we don't duplicate work. Everybody has it. Everybody can develop on it. It's going to be there for a very long time. We've seen how successful that was with tiered storage, graduating essentially from a proprietary feature to an open source feature. and the adoption on tiered storage has just been fantastic. So we wanted to sort of replicate that sort of winning strategy.
Shameless plug also for the folks at home. Satish from the Uber team, who helped contribute tiered storage. I mean, God, I mean, you were saying about not knowing all the numbers. I'm struggling to remember when that came out now, tiered storage, relatively recently, but
Tiered
not that
storage was
recently.
KIP 405. I believe it was originally proposed in 2018.
Nice.
And it took a very I don't know how long it took to like on the scale of like 4 years, I believe, to actually go through all of the design work and the merge work and all of that. So that's part that we didn't want to replicate. We wanted to sort of have this be a 1 year or a 2 year project, and make sure that we can get it into people's hands as quick as possible. And that's another reason why we broke up the KIPs and all of that. So yeah.
Yes, that makes a lot of sense in terms of making things more digestible for maintainers and PMC. Yes. But yes, I should say my reason for mentioning Satish is that he will be on the show, not in the next 2 weeks, but on the episode after that, talking about his work on tiered storage. So save the date, folks at home. I'm very much looking forward to that conversation. Coming back to Discless though, before I get completely sidetracked on being excited about tiered storage. Looking at the kind of broader implications of this. So, okay, we've got various different ways of implementing Diskless topics, or maybe looking at having like tiered hot partitions or whatever. But either way, we're looking at a world where you have potentially Diskless topics that can coexist with your more kind of traditional disk partition backed topics in the same cluster. What does this mean for, like, for example, for like migration or for adoption of either sort of new approaches to using Kafka because of Diskless, or people who are already using Kafka? You know, like what can they do now that they can't do before? Where do you see this having impacts on like the day-to-day life of a Kafka user?
I think so. I definitely think that the focusing on this alternative storage as like a different type of topic and still keeping around the classic topics was really important, especially in the early stages of this, to differentiate it from what has come before. A lot of the other offerings appear to focus on it on a cluster basis. Like, hey, this is, to borrow terms, this is a diskless cluster. You are obligated to use the diskless sort of like mechanism to produce. You don't even have the option of using classic topics anymore. I think that's how several of the other competitors sort of operate. And I feel like that's harmed them in some ways, where they have to claw back like, hey, there's this huge latency hit, but some people don't want a high latency, so we have to like work backwards to get back to the latency of the stock one. Or we are now obligating our users to run multiple clusters or buy more clusters from us, both of which I think are sort of not very good incentive structures. So with being able to have like classic topics and diskless topics coexist on the same cluster, I think it's going to provide like a much better sort of steady state operation as well, because you're able to run sort of your low latency operations on classic topics and run your sort of high scale stuff that is a little bit more latency insensitive on diskless topics, all within the same clusters with fewer migrations and so on. I do think it's also more helpful in the sort of migration to diskless topics. So there is, not currently implemented, but sort of long-term plans are that you can just sort of like flip a topic from one type to the other and have it sort of manage the migration underneath. That is like not designed yet, but is theoretically possible. And that would make it extremely easy to take an existing workload on an existing cluster, upgrade to a version that has diskless topics enabled, configure your backing storage, or even reuse existing tiered storage. And then like when you're ready to like say, hey, application team, can you run this, like, can you switch over to a diskless topic? You don't have to ask them to do sort of latency estimations and all of this different stuff. You can just sort of flip them over and see like, hey, did the world end? Does your application still work? Like, and then if it doesn't work, you flip it back. You don't have to deal with a migration to a new cluster. You don't have to deal with losing offsets or dealing with duplicate data delivery. All of it sort of managed inside of the same cluster. I think that's a beautiful vision of where diskless topics can go now that it's coexisting with classic topics and in mainstream Kafka.
That's hugely cool, thinking about the option of being able to do classic topic to diskless and even back to classic
And
as
back, yeah.
a
Because everybody wants to revert sometimes.
yes, I was going to say, always want everything to be reversible or create
Yeah.
copies or, set your, I'm trying to remember what it is. It's the old classic Tom Scott SQL at uni story of setting a breakpoint in SQL. I'm going to have data engineers yelling at me about this. I can tell already. But of backing up before you make a change, and being able to do that with Kafka is very cool, particularly when so much of Kafka's function as a distributed log is safeguarding you from making mistakes to hurt yourself down the line.
Yes.
But yeah, that's very cool to imagine that is something that would be possible.
I hope we get to do it.
Who knows? Hey, we've all got our fingers crossed. That would be a very cool thing to see. I know that's having spent the last few weeks reading and hearing a lot about Discless. That's one point that's particularly exciting, is the idea that you could just mirror over a topic and experiment with it in Discless and then convert it back if you need to. Circling all the way back to, I think, the very beginning of our conversation, talking about why Discless, other than that it's a thing that people do. Why is it so useful for saving on cost? So coming back to this cross-zone data transfer cost in a cloud environment, this being a big driver for doing this work. Can you talk a little bit more about how Diskless specifically is eliminating this kind of cloud tax for ingress and egress of data?
Yeah, sure. So in a traditional highly available Kafka deployment, you want to have multiple replicas of your data so that if one replica falls over, you still have it. You're still able to read from it. You're still able to write to it. I think that there's a lot of industries where data loss is just intolerable. You cannot pay for it. You cannot sort of risk it. So people run with 3 replicas very commonly. The next step, once you're in the cloud, is now you want to be tolerant to not only one machine going down, but a whole data center going down. So let's say that that single machine fails, you're tolerant of that. But if all 3 of your replicas are in the same data center in the same rack, and that rack has a power outage, suddenly your data is still lost. And if somebody clips a power line coming into a data center and the data center is offline, you're out of data again. So very commonly people have those replicas in different data centers. And one of the things that we've seen happen in cloud pricing is that you are charged for data that you send between data centers because it relies on relatively expensive internet links, fiber links between those data centers. It isn't just sort of copper inside of a data center that's short runs. It's miles and miles of fiber. And the clouds are making people pay for it. So I think the classic is 1 cent in, 1 cent out, which when you're talking about gigabytes, terabytes of data traveling through your Kafka cluster becomes a very, very substantial cost. And in the modeling that we've done of very high utilization clusters, so where you're making very efficient use of your machines, if you're choosing very cost-effective machines, if you're optimizing your sort of storage, you don't have a lot of extra empty disks attached to it, the cost of that data transfer can be 80 to 90% of your operating cost of your cluster. It becomes an overwhelming cost once you've optimized all of the stuff that's easy to optimize. And transferring data between data centers with classic topics, you can't optimize that. The data has to get across, otherwise you're not replicating it.
That makes sense. Yeah, it is such a crazy figure that 80 to 90% number. It feels kind of insane. To be oh yeah, whatever way you do Diskless, you can end up then having such a significant saving. I mean, yeah,
yes,
huge for Kafka. Again, circling all the way back to the beginning of our conversation, definitely not making notes as I go. I think I really liked your answer to, what's it like being an open source engineer as opposed to someone working on necessarily enterprise software the full time. And you're like, oh, it's fantastic, which again, I love that. And I totally get that feeling of like, oh, building something that people get to share and work on together is like super cool. What's your advice for developers who maybe want to get involved in contributing to projects like this one, or maybe people who aren't an engineer yet but would like to work as an open source engineer, or people who are already working on closed source who maybe want to work on open source? What would be your advice to them?
I think that the best way to get involved in open source is to get annoyed with something you're using. So if you have a piece of software that you're using and it frustrates you in some way, and it happens to be open source, I guess that's the key problem. If it frustrates you in some way, turn that frustration into motivation to get involved, to go fix a problem, to go improve it, even if it's just for your case. So like I know that there's software I've been using where it breaks in my use case. I really want it to be like not broken. I'm not like going to wait for somebody else to fix it. So I get involved and I try and figure out what is going on, how does it work, why is it broken, and once you're able to do that, you're able to like make the change. You're able to ask people for help about it because you're now looking at software and you can generate concrete questions instead of a like, hey, I'm looking to get involved. What do I do? It's, hey, it breaks when I do this. Why? I think that's a much, much better place to get involved in the community, and is a lot of how I got into it. And so I guess like I feel like it works. But yeah, having a problem that you want to solve and bringing it to the community is like a really, really good start. And the sort of skills for interacting with the community come naturally out of that because you're talking to people about software, you're working with software you haven't seen before, that sort of stuff. So yeah, that's how I would answer that.
That's such a great answer. Honestly, I relate so much to the feeling of like, oh, I'm using this open source tool. It's so great. Oh, no one's maintaining it. Oh no, now I am the. It is now my problem if I want to keep using it.
Yes.
No, such a good answer. Super cool. And thank you so much for this conversation, Greg. I've really enjoyed chatting today, and for your insight. It's been awesome.
Yes. I had a fantastic time. Thank you so much, Hugh, and thank you so much to our audience. I hope that everybody got something out of this.
I hope so too. Awesome. Thank you so much. And again, as Greg says, thank you to everyone who joined us live for another episode of Get Kafka-Nated. Don't forget to check out the new blog over on Substack and watch this space for later this week, the first blog on Diskless performance. If you're interested in trying out anything you've heard about in today's conversation, it's a good place to start. You'll find configurations, benchmarks, and all the technical details we couldn't fit into our time together today, all at getkafkanated.substack.com. Next time, we'll be exploring the intersection of Kafka and Iceberg with Alec Merced from Dremio. Super excited for that. I know Iceberg is, if you pardon the pun, Iceberg is the new hotness. If you've got topics you'd like us to explore on the show, or would like to be a guest, or have feedback on today's episode, please reach out to me on LinkedIn. We're always looking for new voices and perspectives from the Kafka community. Thank you, everyone, for listening.
Yes, thank you.